absolute value of x plus 2 equals 1, we can rearrange this equation to make it equal to 0. So we subtract 1 from both sides, and we can draw it as a y equals equation. And so we're looking, the y equals graph here is going to be this graph right here, and we already know that the solution to it is -3, -1. And we can see clearly then that because the shape of the graph is going to give us a solution here and here. Okay, so there's our -3, and here's our x equals -1 solution. So because we have this V-shaped graph, we can have two solutions. It is possible because of the shape of the graph. Okay, and again, we want to look at math in terms of shape. Okay, and this shape allows us to justify the two solutions. So why does absolute value give us equations, give us two solutions? Okay, so the absolute value, the V shape of the graph allows the graph to cross the x-axis at 2 points. So it is possible that, and it perfectly justified that we could have two solutions. Now, if the shape of it allows us to have two solutions, is it possible that we get no solutions? And if so, why? Okay, so looking at this graph, well, is it possible to have no solutions? So yes, it is possible. Okay, now maybe we don't quite understand the math yet, but we can physically see that it is possible to have no solutions. Okay, because a V-shaped graph could look like this, and it has at no point did it cross the x-axis. Okay, meaning that if we make the equation equal to 0, there's no solutions in here. Okay, so physically, that's one way you can explain things in math. If we have a physical model, we can say physically it doesn't cross the x-axis. But why is it that, so this is an example physically, but why is it algebraically that we could have no solutions? Well, if we think back to this issue here of how we undo or solve absolute value, solving absolute value looked like this. Okay, and we got our two possibilities this way. But what if that's negative? Will it even go through absolute value? Or maybe the other question is it possible to output going in this direction? Is it possible to get an output of negative when we do absolute value? Well, the answer is no. So what happens then if we try to put that negative through here? It doesn't work. It doesn't happen. We can't do it. And so why is it that we can get this graph that looks like this? Okay, so I'll give you an example here. So this is an absolute value equation that has no solution. So I'm just going to make one up. X plus 3 equals -4. So the output of the absolute value is equal to the negative. Well, we know that's not possible. So when we undo this, there's no solution to this. It's not possible. We cannot go this way to get negative. So the output, when we try to undo this, is not possible. Okay? Now, why will it give us a graph that looks like this? Okay, well, let's see. Well, what did we do last time? To see this graph here, okay, I'm just going to pull it down. To see this graph here, what did we do? Well, we made it equal to 0 and then made it y equal. So let's make it equal to 0, y plus 3 add 4 to both sides to make it equal to 0. And then we can make it y equals absolute value of x plus 3 plus 4. Okay, and that's my graph. Well, this graph has a vertex. Well, it's at -3, positive 4. Well, if my vertex is at -3, positive 4, will this V shape cross the x-axis, or in other words, will it equal to 0? Okay, because that red line is where it's equal to 0. No, it's not possible. So physically not possible, because algebraically there is no output that gives us a negative here. So when we rearrange it, it ends up giving us a shape like this. And those two things are consistent. We get these non-solutions because of this. Now, we have to be careful because we can actually solve this algebraically, and we're going to end up with something called extraneous solutions that we saw before.